All right, now it's time for everybody's favorite trig functions. So we're going to look at integrals of trig functions. But as you know, since integration is the opposite of derivatives or the inverse of derivatives, we're very limited to what we can integrate. We can only integrate things that we know are results of derivatives. So the first thing we're going to do is make our list of derivatives. And it's listed below, and if you forget sine or secant and tangent, secant uses mnemonic pst. Secant was secant tangent, tangent was secant square, and so on. Most of you have that memorized. And you have the advantage also, since this is online, that when you are taking a test or a quiz or a homework, you can look at that chart. But if you are planning to go on to calculus in college, you'll probably want to try to memorize this stuff. I mean, keep the list with you so you can refer to it, but try to memorize it. It will help. So anyhow, let's get back to the integrals. The integrals are the opposite of derivatives. So since the derivative of sine is cosine, that means the integral of cosine must be sine. So that's how everything works. We know that the derivative of secant is secant tangent, so we also know the integral of secant tangent must be secant. So all you need to do to get the integrals is this. If you noticed, shoot, that was wrong, but go ahead. If you notice, all you have to do is flip your derivative chart, just look at it backwards. Bring the negatives over with it. So there you have a easy integral chart. Integral cosine is sine, sine is negative cosine, secant squared is tangent, and so on and so on and so on. All right, on the end of your notes, you'll see a more organized chart for that, but that's all there is to it. Notice we can't integrate, say, just like secant. Secant is not on the chart. It's a result of an integral, but it's not an integral itself. So that's it. Integrals, you can only integrate what you already knew as far as differentiation went. So our integral formulas, our basic integral formulas are here. You'll see the power rule here, all the sum and difference, and here's all the trig ones that I just went through. And that's it. There's nothing else you can do. So never make up your own rules. If we were in class, you'd hear that 500 times. You're not in class, so you'll probably only hear it 250 times. Don't make up your own rules for integration. There are none. You just have to go with what you got. Also, one last final warning. See the power rule? It says it works for n does not equal -1, which means we just can't integrate x to the negative first. It's read down here. It says we'll get to that in chapter 5, and we will get to that in chapter 5. So let's do a couple trig functions. The first one is the integral of sine. Whoa, that's a mistake. So here's a good time to point this out. Remember that dx on the end of integrals. That means that's the function we're taking the derivative or integral with respect to. So to be able to integrate this, because there's a dx here, the variables have to be x. In this case, and this is my mistake, they're thetas. So I'm going to have to change this. The best way to do it is, I'll do this. Let's make this d theta. So that's the best I could do. That's a theta. So now it says the integral of sine theta minus cosecant squared theta d theta. So that just means with respect to theta. So the integral of sine is, look at the chart, it's negative cosine. And the integral of cosecant squared is negative cotangent squared. And that's it. So it's just negative cosine theta plus cotangent squared theta plus c. And if you do a quick derivative of this, because we're more familiar with that, you'll see you have a negative sign, which is sine, and I just screwed up again. So this is, we're going to keep this screw up here because it works good with my check here. I see how I said cotangent squared theta. Its derivative is, well, it's not cosecant squared theta. So here, that really points out the importance of checking. I don't know what happened to me here, but the integral of cosecant squared is not cotangent squared. The integral of cosecant squared is just cotangent. I didn't look at my chart, I guess. So let me erase this. So there was my mistake. I'll mark it at -1. So here's my corrected answer. And you can see now when I check, when I take the derivative of cotangent, I do get negative cosecant squared and it checks. So that's the importance of checking. Last example. The integral of secant tangent minus t plus 1 dt. So everything says with respect to t. All my variables are t, so here we go. The integral of secant tangent, according to our chart, is just secant t. The integral of t, you just use the power rule. You add 1 to the exponent, t squared, times 1/2. And the integral of 1, usually it's x, but since we're doing it with respect to t, it's t. Add your plus c. That's it. You can check me on that one. If for some reason I did that wrong, let me know about it. That video was a little bit longer than I wanted it to be, but a lot of good things happened out of it. So make sure you check. See you next time.